This is to explore, non-theological exploration of the existence of God. Every single human being in the world would have one day in their life, if not often, wondered about the universe. How did it begin? Does God exist? Is there a creator to this universe? Or as the atheists say, did all of this happen by chance? Well, every day we hear the theists, like Christians, Muslims, Jews and Hindus, say yes, there is a creator. But that is a theological view. A religious view. Are there any scientific evidence for the existence of a creator? Is there even a chance, or has science proven that there is no creator? And that the universe came to be, as it is now, purely by chance? Have you ever pondered over this question? Sure you have. Let's do a bit of research. Even if we can show that something created the universe, how do we know that it created us on purpose? Couldn't we just be an accident? Is there any reason to believe that the universe isn't just random? How do we know that we are not just a cosmic hiccup? Recent research in cosmology has shown that the universe has to have a specific set of conditions in order for it to sustain life. So we can actually calculate how likely it is that a randomly designed universe would have these conditions necessary to support life. These conditions are so improbable that most physicists believe that they couldn't have happened by chance. 1. The very special initial conditions of the universe. 2. Constants in the physical laws governing the universe are fine-tuned for the possibility of life. 1. The initial conditions of the universe. Let's take the 2 laws of thermodynamics. These laws are about energy, order and disorder in systems. 1. Energy. The first law of thermodynamics. The energy in an isolated system is constant. For example, imagine a rock is at the top of a hill. It has a lot of potential energy due to gravity. When the rock rolls down the hill, it gathers speed. So the kinetic energy of motion increases as the potential energy due to gravity decreases. Potential energy is converted into kinetic energy. Now, if the rock runs into something at the bottom of the hill, that kinetic energy is converted into heat energy. Whatever it runs into and even the air it moves through will increase a bit in temperature. Carpenters know this, because when they hammer a nail in a bunch of times, the nail heats up. Energy can change form, but the total in a closed system remains constant. 2. Entropy, the second law of thermodynamics. Entropy is a measure of the disorder in a system. Low entropy means a very organized state. High entropy means a disorganized state. For example, iced tea. If you took hot tea and put it into a thermos with ice in it, what will happen? The hot tea will melt the ice and it will get cold. Some of the ice will melt and become cold water. Over time it will all mix together and you'll get cold tea. And it always happens this way. Could you put iced tea into a thermos and expect it to change into hot tea and ice cubes? No. In a closed system, over time things are going to mix together. The hot things will always cool down, and the cold things will warm up until everything is at combined temperature in the middle. The level of entropy always goes up and it doesn't go back down again. This is why most of the processes we see around us only go in one direction, from order to disorder. 3. The entropy of the entire universe. The universe is a closed system, because there is no energy source outside the universe that can transfer energy into or out of it. Why? Because everything that affects the universe is inside the universe already. So the entropy of the entire universe is always increasing. That tells us something about the past as well. As you go into the past, things get less and less random. So that means at the beginning of time, in other words, at the Big Bang, things were highly organized. Says Sir Roger Penrose. Roger Penrose comes from a family of mathematicians and has a PhD from the University of Cambridge, St. John's College. Sir Penrose is an English mathematical physicist, mathematician and philosopher of science. He is the Emeritus Rouse Ball Professor of Mathematics at the Mathematical Institute of the University of Oxford, as well as an Emeritus Fellow of Wadham College. Penrose is known for his work in mathematical physics, in particular for his contributions to general relativity and cosmology. He has received several prizes and awards, including the 1988 Wolf Prize for Physics, which he shared with Stephen Hawking, for their contribution to our understanding of the universe. 4. How unlikely is this low entropy start to the universe? How special was it? You can actually work this out. It's so special that the odds against this special initial state coming about by chance are less than 1 part in 10, to the power of 10, to the power 123. This is fine-tuning. This is incredible precision in the organization of the initial universe, says Sir Roger Penrose in The Big Bang's low entropy condition. 10 to the 10th, to the 123rd, against our universe. If you wrote out every 0 in 10-point font, it would fill most of the Milky Way galaxy. As per the calculation of the universe being fine-tuned to such precision, it is a part of a number we cannot write down, which means there is absolutely no chance for the universe to be so fine-tuned for life, purely by chance. Which proves, there has to be a guide, or rather a divine planner. If it is the universe, then the universe has to be alive, and ever calculating. 6. Low entropy is necessary for life to exist in the universe. We needed a very low initial level of entropy in the universe to get suns and planets, and ultimately life. Suns and planets could not have formed if the universe began with high entropy, and life could not exist. Let's take a look at the constants of the universe. A. Physical laws of nature. The physical laws of nature rule how things work in the universe. The law of gravity, the laws of motion, laws of electromagnetism, and the laws of thermodynamics we mentioned earlier. A constant is a number in the mathematical equations for the laws of nature. It is the same everywhere in the universe and over time. A constant never changes. For example, the speed of light in a vacuum, the mass of a proton, the mass of electron, etc. For example, consider the engine of a car. There are many possible ways that an engine could be made. It has various parameters that could be changed to make the engine run better: the size of the pistons, the fuel, air mixture, the timing of the spark firing, the idle speed, etc. This requires careful engineering. B. Fine-tuning of the constants. The laws of nature could still work with different values for these constants. There is no scientific reason why they have the exact values that they have. Physicists have discovered that if any one of several of these constants were altered in even minor ways, life would not be possible. Here are some examples. 1. Gravitational constant. If the weak force constant or the gravitational constant were higher or lower, by just 1 part in 10 to the 50th, then either the universe would have kept exploding forever. You can see that's very bad for life forms, or it would have catastrophically collapsed, also not good for life. 2. Strong nuclear force coupling constant. If the strong nuclear force coupling constant were just 2% higher, there would be no hydrogen in the universe, and that means no stars and no life. But if it were just 2% lower, there would be no elements heavier than hydrogen, and that means no carbon as the building block for life. So either way we're out of luck. 3. Constants determine possible types of stars. Stars that can support life, like the Sun, lie right between two extreme states that are hostile to life: blue giants and red dwarfs. If electromagnetism, the gravitational constant, or the mass of the proton relative to the mass of the electron vary from their values by a super small fraction, either higher or lower, then all the stars in the universe would be either blue giants, emitting tremendous amounts of radiation and frying everything in sight, or red dwarfs emitting so little radiation that life would never have a chance. Once again, just a fractional difference would make life impossible. 4. Carbon resonance energy. Just take a look at this profound statement made by Sir Fred Hoyle, who is a renowned atheist, and a most respected English astronomer who formulated the theory of stellar nucleosynthesis. Finely tuned resonance energy of carbon was necessary for carbon-based life forms to exist. A common-sense interpretation of the facts suggests that a super-intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me to be so overwhelming as to put this conclusion almost beyond question, says Sir Fred Hoyle, in his book titled, The Universe, Past and Present Reflections, Engineering and Science. The only alternative to the universe arising from chance is for it to have arisen deliberately. Deliberate action requires a conscious creator. And for those who are still tempted to conclude that our universe is just the result of a very extremely improbable accident, try to think of the improbable chance calculated by Sir Penrose. Think of this number. The accuracy for the universe to support life as it does, has to be accurate to 1 part in 10, to the power of 10, to the power of 123, that is 1 followed by 10, to the 123rd power zeros. Do you understand this number? Even Sir Penrose goes on to explain in his own words, that is a number which it would be impossible to write out in the usual decimal way, because even if you were able to put a zero on every particle in the universe, there would not even be enough particles to do the job. As argued by Klaus Landsman, the education coordinator, master mathematics and professor at the Radboud University, he says that this number calculated by Sir Roger Penrose is arguably the largest number ever conceived by human beings. Thus, the chance of the universe coming to be by chance is so thin, it will be the smallest chance calculated as a probability ever to be understood by humans. That is, if we ever did understand how small that chance is. Moving from fundamental forces to initial conditions, the solar system seems fine-tuned for life in various ways, most notably in the distance between the Sun and the Earth. If this had been greater, or smaller, by at most a few percent, it would have been too cold, or too hot, for at least complex life to develop. Furthermore, to that effect the solar system must remain stable for billions of years, and after the first billion years or so, the Earth should not be hit by comets or asteroids too often. Still wondering? Have you just received too much information? Let's look at a simple argument put forth by Professor Landsman. If a dice is tossed a large number of times and the number 2 comes up every time, one would expect the dice to be loaded, or the person who cast it to be a very skillful conman. Once again, each outcome was assumed equally likely. For a pair of dice to show 2 the first time, that would be the probability of 1 part of 12. For this to happen twice, that would be 1 part of 144. That is the probability of 0.007, which is next to impossible. Unless some magic or trick is at work. Now imagine this happening a phenomenal number of times. The probability is almost 0. Which means, it is not probable to be the work of pure chance. There has to be a planner, a schema. In the case of the universe, with that level of fine-tuning, this also requires a planner, a schema. Vis-a-vis, a creator. There are analogies and differences between cosmic fine-tuning for life through the laws of nature and the initial conditions of the universe, as discussed so far, and evolution in the sense of Darwin and Wallace. The latter is based on random, genetic variation, survival of the fittest, and heritability of fitness. All these are meant to apply locally, that is, to life on Earth. Science has proven that there has to be an intelligence behind the fine-tuning of the universe to sustain life. If not, life as we know would not exist. Conclusion. There is an intelligence in the universe. You may call it creator, you may call it God. Thank you, and cheers to you.